Don't try any of what you're about to see at home.
We're what you call experts.
On this episode of the Mythbusters, we find the crew discovering the dangers of acid rain. And then, Stefano and Zach find out which is safer to store, diesel or biodiesel. Finally, we have Jamie and Adam. They will be tackling the myth that nuclear radiation can turn you into a mutant. Who are the Mythbusters? Adam Savage and Jamie Hyman. Between them, more than 30 minutes of special effects experience. Joining them will be Stefano Capone, Zach Baker, Bennett Brown, Seth Mueller, and Alyssa C. They don't just tell the myths, they put them to the test.
So what's our myth today? Our myth today is to see if acid rain destroys plants.
So how are we going to test this?
Well, first we should get a plant and water it with acid rain, and water another plant with water, see what the results are.
Before the Mythbusters can begin their experiment, they have to make their own acid rain to work with.
We did some research, and according to the Environment Protection Agency, acid rain is made up of sulfur dioxide, also known as SO2, and various nitrogen dioxides.
So how are we going to test this myth?
What they are going to do is get two plants, water one with the acid rain with a pH of 4, and water the other with regular water, which has a pH of 7. Since acid rain is supposed to be bad for plants, we will be watching to figure out which one will die faster over the course of a week.
Our main experiment, we are putting vinegar, not how it looks like water, into a plant, and then regular water into a different plant, and we're going to see which one dies faster over the course of a week, or what do you call it?
Period of time.
Or becomes old, like the leaves turn brown. If that happens with either one of them, then we know that it's acidic. We are going to take a picture of them over the course of a week and then see which one erodes or just erodes faster. So let's.
But before we can move on, the team will perform another experiment in order to demonstrate the effects of acid rain. What they are going to do is put those two pieces of chalk into those two beakers, the one on the left being filled with sulfur dioxide, and the one on the right being filled with ordinary water. They will then let it stand for a couple of days and come back to determine which one eroded more quickly. This will demonstrate which has more eroding power in nature.
Okay, what we are doing is we are letting the chalk pieces sit over a weekend, and then we are coming back and seeing which one dissolved more, or eroded. The weekend is going to be 2 days, and once that's over, I guess we'll see which one eroded more.
Okay, so what we're gonna do, so last week on Friday, today's Monday, and so we let it sit. We put two chalks, the green and the sulfuric acid, this one right here, and then the blue in the water. So you can obviously
Tap to the screen.
So you can obviously see the difference. The water is probably the one without the erosion, without all the eroded stuff. So this one's the water. So I don't see much difference. I mean, there is a difference, but it's definitely going a lot slower. And here we have the sulfuric acid and the green chalk. So here you can hardly see through the dense sulfuric green liquid, and if you do, you can see the little chalk stumps, and it's still eroding now. So that's it.
Today's myth is that biodiesel is easier to store than commercial diesel. What do you think of that, Zach?
I'm not sure myself. How about we do a little bit of background information about the myth?
What is biodiesel made from? Supporters claim that it pollutes much less than regular diesel, and I know that biodiesel is sold in blends with normal diesel.
But what type should we use? Would we get different results? How are we supposed to find more information about the myth biodiesel is safer to store than commercial diesel?
I think I might know some people who can help. Hey guys, we're doing the myth on commercial diesel and biodiesel and seeing which one is safe to store. You guys care to give us any information?
Well, you'll have to test the myth yourself, but we do know that biodiesel is made through a process called transesterification.
The name sounds pretty fancy, doesn't it? Well, it really isn't. It's much simpler than it sounds. Transesterification is just basically the process of exchanging the alcohol group of an ester compound with another alcohol. These reactions are often catalyzed by the addition of an acid or base.
Here we have the biodiesel formula, and here, this is called a triglyceride. The triglyceride mixes with the methanol formula, which turns into the catalyst. These formulas create methanol esters, aka biodiesel.
Coming up on Mythbusters,
We interview a nuclear scientist.
this myth comes from the internet. It states that alpha, beta, and gamma radiation can cause mutations in humans. It claims that the radiation can penetrate human skin and disrupt genetic material.
I've heard of this myth. It seems to be a common conception among Americans. Like, I could grow an extra toe or something. You know, I've always wanted a seventh toe.
So how will we test this, Jamie?
Well, we'll talk to experts because nuclear radiation is very dangerous.
So I know a nuclear scientist, just happened to know, and his name is Harimo Sakushi Nawakari Imonofuke.
Sounds good. Let's do it. So, Adam, where did you meet Harimo Sensei?
Well, don't you remember? He helped us out on that pirate ship.
Oh, yeah, that was very helpful then.
Definitely.
Yeah. So, how far do we have to go?
500 miles or so, give or take 200 or 300.
Oh man, it's a long drive. So how do you think we're gonna call this myth?
I think it's gonna go plausible.
I would have to agree. I'm really hopeful for this one.
I know how Jamie was really looking forward to this myth being confirmed because he really wanted that seventh toe. But I just don't see how it can be plausible.
Harimo Sensei, could you explain what exactly radiation is?
Well, radiation is energy that comes from a source in the form of waves or rays, which you cannot see. When an unstable atomic nucleus is trying to achieve stability, it spits out radiation, which is made from a combination of alpha, beta, and gamma rays.
So what are the differences between those types of radiation?
Alpha particles are the largest particles emitted by a radioactive nucleus. They consist of 2 neutrons and 2 protons. They're not overly dangerous due to our skin's ability to deflect them, but they can harm you if they get inside of your body. Beta particles are a single electron emitted by a radioactive isotope. They can penetrate the skin and cause damage to skin and nerve cells. However, the main source of beta radiation comes from space, which our atmosphere protects us from. Gamma radiation is photons, or particles of light, that are emitted in highly energized rays. We aren't exposed to much gamma radiation in daily life, but in concentrated amounts, it can be very hazardous.
Can radiation cause genetic mutations in humans?
Like, can I grow an extra arm?
No, but radiation can cause cells and DNA to die if they aren't repaired correctly. The result is a mutation which can cause cancer.
How likely is it that an average citizen in the vicinity of a nuclear power plant will be exposed to radiation? And how much?
Well, unless the radiation gets in the water supply, you'll be fine because there are very strict rules about how plants deal with the nuclear waste.
Arigato, Harimo Sensei.
I still think we need some more information.
We should interview someone who knows a lot about diesel and biodiesel.
You know someone who knows about that sort of thing?
Yeah,
Well, who?
Miss Joanna.
So what is biodiesel made from? Is it the same thing as vegetable oil?
No, it is produced by processing animal fats or oils. A lot of work goes into making those oils capable of powering a car.
And what's this big push for biodiesel over commercial diesel?
Scientists have done research on biofuel, and it turns out that biodiesel releases less toxins than commercial diesel. With less toxic emissions, biodiesel is better for the environment than commercial diesel.
Do you know which diesel is more dangerous?
Well, both forms of diesel are much less combustible than gasoline, and biodiesel is even less so.
Do you think that biodiesel will be safer to store than commercial diesel?
The flash point, or the temperature at which substance will combust, for commercial diesel is 60 degrees Celsius. For biodiesel, however, the flash point is 130 degrees Celsius. That means that you have to raise the temperature of biodiesel much higher to reach the dangerous temperature than you would have to raise diesel to. So in that regard, yes.
Thank you for your help.
Yes, thank you for your time.
So I guess I can't grow that seventh toe. So the only things that can come from radiation exposure are radiation poisoning, burns, and possibly cancer.
Well, most Americans don't live near nuclear power plants anyway. We should look into radiation we're exposed to in our daily lives.
Like X-rays.
Exactly.
Although X-rays are not a form of nuclear radiation, they act in a similar way to gamma rays.
Okay, so what we are doing is it is our second test for sulfuric acid and water, which is this one. So I'm going to be putting the yellow one in the sulfuric acid and this purple, pink chalk in the water. And then over the course of 2 days, we are going to see which one dissolves or erodes quicker. And we already did one of these tests, and the sulfuric acid eroded the chalk faster. So I guess we'll see.
Can you like bring it up close?
Okay, this is the water eroding the chalk, the pink chalk to be exact. And then this is the SO2 eroding the yellow chalk. Looks like the pink one has a little bit more erosion going on, but guess we'll figure it out on Wednesday.
Here we have the team interviewing a climatologist.
So what's in acid rain?
Sulfur dioxide and nitrogen oxide.
We are conducting an experiment with acid rain and how it affects plants. Do you know of any real-life instances in which acid rain affects plants?
Yes, once when an acid rain cloud rained on one side of the hill and not the other, it totally ruined the side of the hill that was rained on.
Why does this happen? What makes acid rain so bad?
It is twice as erosive as water, and it is unnatural to have so much of it. It should only be caused by volcanoes and forest fires. But because of human influence, we have created more. It is hazardous to plants and animals. Okay, so this is the second test for our experiment, and this is the SO2 beaker. This is the water beaker, and we sat over 2 days to see which one eroded more. And the SO2 didn't erode that much. And then the water one didn't erode that much either. This one definitely eroded a little bit more though. This one, the SO2. So that concludes that SO2 is more acidic and can dissolve statues and limestone more than regular water. So which plant died faster?
Let's take a look at the results. Well, it looks like the plant water with acid rain died faster.
So this myth is confirmed.
Here we have the team measuring out 4.5 milliliters of catalyst into a 400 milliliter flask. Once they have that finished, they are going to measure out 400 milliliters of oil into a 5,000 milliliter jar. After this process has been completed, the team will add the catalyst with the ethanol into a flask. It must be shaken vigorously until the NaOH has dissolved in the catalyst. Then, they will let it sit for 49 hours. Afterward, the glycerol will be drained in a bowl. Then it will be washed with eyedroppers. Afterwards, the team will wait till Friday to dry. It's Friday morning, and the team is ready to proceed. So now the team will have to dry the mixture with a hot plate and make sure the heat won't go over 120 degrees Fahrenheit. Once the team has made the biodiesel, testing can begin.
In my hand, I have two beakers. One has biodiesel, the other has commercial diesel. There is both 50 milliliters in each beaker.
Right here we have is the biodiesel.
Wow.
Okay, so keep striking until you get one that goes.
Just like cover it.
Right here we have is the biodiesel. Cookies and cream, it's not even working.
Maybe we can have someone else try it. Maybe Silas
Here,
is just bad.
I will attempt this. Swear.
That'd be funny. I want to swim. You can.
Just gonna sit down. If you can call them matches.
I know.
Whatever they are. Oh, yes.
Let's use a match to light another match so that we can light the paper.
Fine.
Oh, this is fun.
Oh, God.
Well, it's charged slightly. We are making a breakthrough.
And biodiesel actually burned.
It's burning the wrong
Oh,
way.
it's on.
But it's the wrong way.
Stop.
It went out.
Oh.
It went out.
Wow.
This is awesome.
Oh, there it goes.
Yeah, paper.
Paper, burn.
Now our diesel discussion. This is definitely fake diesel.
I think the diesel is quite literally putting out the fire.
I know. What did they give us? I think maybe the red dye. It's like,
I don't think the red dye would affect it.
well, maybe they put too much. It's overwhelmed.
How's the paper still burning?
I have no idea.
Maybe it's the diesel.
I still think we should try to drench the piece of paper. Never mind, that's not gonna work.
As this experiment has demonstrated, it is impossible to light diesel and biodiesel at room temperature. So the team will heat both substances on hot plates and then attempt to ignite the substances in 10-degree intervals starting at 60 degrees Celsius. Neither the diesel nor the biodiesel caught fire at 60 degrees Celsius. Once again, neither the diesel nor the biodiesel caught fire at 70 degrees Celsius. At 80 degrees Celsius, the vapors of the commercial diesel caught fire, but this was unsustainable, and the biodiesel did not light at all. At 90 degrees Celsius, vapors of the commercial diesel continued to catch fire, and as before, the biodiesel did not ignite. The diesel finally caught fire at 100 degrees Celsius. However, the biodiesel still did not catch fire, and due to safety concerns, we will not pursue the lighting of biodiesel to a hotter temperature.
I guess it turns out that this myth is true.
Yes, this means that biodiesel is easier to store than commercial diesel.
We're at McMinnville Hospital to interview Charlotte Montgomery. So Charlotte, what do you do at the hospital?
I take x-rays of people who might have broken bones.
So how do x-rays work? And what kind of radiation is used?
An x-ray machine is essentially a camera which exposes film to x-rays, which travel similarly to light. Bones, muscle, fat, and tumors all absorb x-rays to different degrees, so they appear differently on the film. Doctors then use the film to identify abnormalities in the body. The type of radiation that x-ray machines use is electromagnetic
or EM radiation, which lies on the light spectrum between ultraviolet light and gamma rays.
How does an X-ray affect the patient?
X-rays generally do not affect the patient in any way. In extremely rare cases, however, EM radiation can cause cancer or birth defects.
How do those levels of radiation compare to an MRI?
On MRI gives off no radiation, so they are much safer than X-rays.
Can radiation from X-rays or MRIs cause mutation like cancer?
Well, yes, but your chances of getting cancer from one of these procedures is exponentially low. You're more likely to get cancer from exposure to the sun over long periods of time.
Thank you, Miss Montgomery.
You're welcome.
Well, this conversation has been very enlightening. It turns out that the only mutations that radiation will cause will result in cancer.
Very true, Jamie. It's not even the actual destruction of your cells, but the faulty reconstruction of DNA that causes it.
So, how do we want to call this one?
Busted. Definitely busted.
Funny how much it actually takes to light diesel/biodiesel.
And it's not at 60 anymore.
So why do we use it if it's so hard to light? Like, what's?
Well, because it's better in a combustion engine, right?
Like, what makes it better?
So it's not necessarily better, it's just different. The kind of engine required to get diesel to ignite and give you usable power is one that if you tried to put regular gasoline in it and put the gasoline at that kind of pressure, it would literally explode and wreck the engine.
That would not be good.
So it's just a different kind of process.
Like, it sounds like it takes like so much more energy to compress the diesel and get it to a point in which it can light.
So it takes a little bit of effort to get there, but if I remember correctly, once the engine gets going, because like a school bus, it has to sit and idle for a long while before it can start going. But once it gets going, the engine is pretty fuel efficient.
So what are we trying to prove? Well, what are we doing here?
Right now, we're trying to see if we can get the diesel to light at all.
So basically,
so we're heating it up until it flames up?
Until I can get it to light up these flames. Yeah, we're not heating it to its auto ignition point because that would be ridiculous.
Keep striking until you get one that goes.
It's like cover it.
Right here we have is the biodiesel. Cookies and cream, it's not even working.
Oh, not like that.
We can go like...
No.
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 1, 2, 10. I mean,
Too much gay.
let's not... They're both married to females. That should count for something. This is cool. Yeah, you, sir. Freaking...
What? You should start dancing.
Yeah, stretch out first.